Integration using partial fractions with quadratic factors. We have the question of 3 plus 6x plus 4x squared minus 2x cubed divided by x squared into x squared plus 3 integrated with respect to x. And now when this is resolved into partial fractions, we have that 3 plus 6x plus 4x squared minus 2x cubed divided by x squared into x squared plus 3 is equivalent to give 2 over x plus 1 over x squared plus 3 minus 4x divided by x squared plus 3. And now if we are going to integrate the equation with respect to x, that means we are going to integrate everything here as 2 over x plus 1 over x squared plus 3 minus 4x divided by x squared plus 3, all with respect to x. Therefore, we can split each term. So this will be integral of 2 over x dx plus integral of 1 over x squared dx and plus integral of 3 minus 4x over x squared plus 3 dx. Now let's simplify each term. Integral of 2 over x dx is equals to 2 ln x plus c, because integrating 1 over x with respect to x will give us ln x plus c. Now integral of 1 over x squared dx can be written as integral of x raised to power minus 2 dx, and integrating x raised to power minus 2 will have x raised to power minus 1 over minus 1 plus c, and this will give us 1 over x minus 1 over x plus c. Now how then do we integrate the last term, that is the integral of 3 minus 4x divided by x squared plus 3 with respect to x? Now this can be further simplified to give integral of 3 into x squared plus 3 minus 4x into x squared plus 3, because 3 minus 4x divided by x squared plus 3 is equals to 3 over x squared plus 3 minus 4x into x squared plus 3. Now with this done, we can integrate each term again separately. So let's begin with integral of 3 into x squared plus 3 dx. Now let's recall in our video of integration using substitution of x is equals to a tan theta. Substitution of x is equals to a tan theta. We realize that it is applicable when we are integrating the format of integral of 1 over x squared plus a squared, and we are integrating with respect to x, and this will give us 1 over a arctan into x over a plus c. And in this question, we are asked to integrate 3 divided by x squared plus 3. It can be written as 3 being a constant, brought out, divided by 1 over x squared plus root 3 squared, because root 3 squared is equals to 3. integrated with respect to x. Now we know that in this case that a is equals to what? Root 3. So this can be simplified to give us 3, and we applied the principle here. That's 1 integrating 1 over x squared plus root 3 squared with respect to x will give us 1 over a, where a is root 3, arctan x over a, that's x over root 3 plus c. And this will give us 3 over root 3 arctan x over root 3 plus c. Now 3 over root 3 is the same as, is equivalent to root 3. Therefore this will give us root 3 arctan x over root 3 plus c. And this is for solving integral of 3 into x squared divided by x squared plus 3 with respect to x. Now, having solved this equation, let us now solve integral of 4x over x squared plus 3 with respect to x. Integral of 4x divided by x squared plus 3 with respect to x. Now, this is determined using algebraic substitution of u is equals to x squared plus 3. If u is equals to x squared plus 3, du dx is equals to 2x, and dx will be equals to du divided by dx divided by 2x. So let's change the variable from x to u, and this will become 4x divided by u, and dx is now du divided by 2x. Now 2x will nullify 4x and will be left with 2. And that will be integral of 2 over u du. And integrating 2 over u du will give us 2 ln u plus c. And ln u after making our substitution will give us 2 ln x squared plus 3 plus c. Therefore, integrating 4x divided by x squared plus 3 dx is equal to 2 ln x squared plus 3 plus c. Now let us mark out the important part of the questions. We have solved this integral of 4x over x squared plus 3 dx. Likewise, we have solved integral of 3 over x squared plus 3. Likewise, we have solved integral of 2 over x and also integral of 1 over x squared. And let's go back to our question that we are asked to solve integral of 2x, 2 over x plus integral of 1 over x squared plus integral of 3 minus 4x over x squared plus 3. So because we are dealing with the integral of 3 plus 6x plus 4x squared minus 2x raised to the power 3 is equals to x squared into x squared plus 3 dx, which will give us the integral of 2 over x dx plus integral of 1 over x squared dx plus integral of 3 minus 4x divided by x squared plus 3 dx. And we saw that this was split into 2, and we can do the same here. That's to give us integral of 2 over x with respect to x plus integral of 1 over x squared with respect to x plus integral of 3 over x squared plus 3 with respect to x and minus integral of 4x with respect to x. Now let's pick each term as we have solved earlier. Integral of 2 over x and integral of 1 over x squared. And that will give us 2 ln x plus minus 1 over x, and integral of 3 divided by x squared plus 3 will give us root 3 arctan x over root 3 arctan into x over root 3 minus integral of 4x over x squared plus 3 with respect to x will give us 2 ln x squared plus 3, and everything will have a single constant of integration plus c. So simplifying this, we have 2 ln x minus 1 over x plus root 3 arctan x over root 3 minus 2 ln into x squared plus 3 plus c. Now we can leave our answer this way, or we simplify applying the law of logarithm, where this will become ln x squared and this will give us ln x squared plus 3 squared plus c. Now we can still combine this and this together, applying the same law of logarithm to give us ln x squared over x squared plus 3 squared minus 1 over x plus root 3 arctan into x over root 3 all plus c. It can be left like this, or we simplify further. Since this is x squared and this also is squared, we can now rewrite to give us x squared into x squared plus 3 and everything will be squared minus 1 over x plus root 3 arctan x over root 3 plus c.